Topic number 5, review factoring trend polynomials. There are actually 6 topics, 6 types of factoring polynomials. We really only gonna encounter about 4 of them. So some of the things that you saw in topic number 4, we actually now gonna do its opposite operation, which is actually factoring. Or in a way, you can say we are talking about division of polynomials. Okay, so factoring is basically a division of polynomials. First thing first, first type out of the 6, factoring what we so call the greatest common factor. So earlier in topic number 4, I mentioned something about find the LCD between 3 and 4. So let me show you a different way. Finding the LCD is about counting the repeated and the non-repeated factors. Oops. Let me 3 and 4, for example. If I want to find the LCD, what I do is write 3 as 3 times 1 or just 3. Prime factors makes 4, 2 times 2. LCD is about finding the repeated factor and the non-repeated factors between the two denominators. The 3 did not repeat with the other sets of factors, so you count that one time. This 2 did not repeat with another set of factor 3 with the 3, so you count that one time. The 2 did not repeat with another set of factor, you count that one time. So least common denominator is about counting the repeated factor and the non-repeated factors. So that's why when you multiply this together, you get 12. Greatest common factor. I gotta use a different example. If I do greatest common factor between maybe like a 25 and a 30. 25, I know prime factor makes up 25 will be 5 times 5. 30, I know is 5 times 6, but the 6 is 2 times 3, right? 6 times 5 give me 30. So when you write them out as prime factors, what you do for greatest common factor is to only count the repeated factors. So between the two terms. So these two repeated between the two factors. Count that one time. This 5 did not repeat with another set of factor, so you don't count that. 2 did not repeat, 3 did not repeat. So the greatest common factor between 25 and 30 is actually just going to be 5. So finding the greatest common factor versus finding the least common denominator is quite different. It's about how you count the repeating factors and the non-repeating factors. So to find the greatest common factor, we use prime factorization like I did to break down the terms, and then we count all the repeated factors. For the variables, so if I'm attaching variables with my terms, then you always choose the smallest exponents because the smallest exponents repeats. Okay, they're the factors of the exponents of the variables repeats. That's why you choose the smallest one. So if I attaching x squared and x to the third, 25x squared will be 5 times 5 times x times x. 30x to the third will be 2 times 3 times 5 times x times x times x. So if you only count the repeated factors, you will only count the repeated factor 2 times. So this x did not repeat, so you cannot count that. So that's why for variables, we choose the smallest exponent, 5x squared. So these examples here are polynomials. We're going to find their greatest common factor first, factor it out, and we write what's left of it between each terms inside the parenthesis. So normally do the coefficient first. Greatest common factor between 2, 22, and 10. The only repeating factor between 2, 22, and 10 got to be 2. Now the variables. All right, x squared, x to the third. X repeated between all three terms, you count the smallest one, which is x squared. Y to the third, no y, no y. So y did not repeat, so we don't have any y as the greatest common factor. So my greatest common factor is 2x squared. So we factor out the greatest common factor, then we say times, open parenthesis. So now is when we perform the division. What we are really saying here is 2x squared will go into the first term how many times? 2x squared will go into 2x squared y to the third how many times? So basically what we are performing is quotient rules on the exponents. Okay. So the way I would normally say it, I don't write it this way. Normally the way I say it is 2 going to 2 one times. You took both x to the outside, so no x left for the first term. You did not take any y to the outside, so your first term should left you with y to the third. 2 going to positive 22, positive 11 times. You took both x's to the outside, so no x left for the second term. 2 going to positive 10, positive 5 times. You factor out 2x is all of the 3. So there should be 1x remaining in the parenthesis for your third term. So that's it. That's how you factor out the greatest common factor. And the best way to actually check if you factor completely, okay, the best way to check if you factor completely is to check what's inside the parenthesis. Okay, you always check inside the parentheses, see if inside the parentheses can be factored again. So since I already factored out all the greatest common factor on already, then when I check inside the parentheses, there should be nothing else can be factored out. A lot of people say the best way to check if we factor completely is to multiply them out, and that is not true. That will actually not that does not always work. Okay, because what happened if I did not factor out the x squared, only factor out the 2? Then when I remultiply, I will still come up with the same thing, but your answer is actually not factored completely. So the way to check if you factor completely or not is to check what's inside the parenthesis. Let's try another one. Okay, greatest common factor between 6, 45, and 21. 6, 45, and 21. We know 6 is 2 times 3. We know 21 is 3 times 7. So I don't say 3 twice. And 3 can actually be used, is actually inside the 45 because 45 is 4 times 9, 5 times 9, and 9 is actually 3 times 3. So the only common factor repeat between 6, 45, and 21 got to be 3. Check for the variable. X to the third, x to the fourth, x to the third. So choose the smallest one, which is x to the third. Y to the third, y squared, y. Smallest exponent between the y is y to the first. So that's my greatest common factor. Then we say times, open parenthesis. And let's see what's left over between, from each one of the three terms. So let me show you what I mean by that. 6x to the third, y to the third means 2 times 3 times x, 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 y, y, y. If I'm already factoring out 3x to the third and 1y, then what should be left will be 2y squared. Whatever I did not circle should be what's left over. So 3 going to 6 two times. I took all three x's to the outside, right? No x left for my first term. I factor out 1y from 3 of them, so y squared should be left. Second term, 3 going to positive 45 is positive 15. Took 3x from 4 of them, 1x left for the second term. To 1y from 2 of them, 1y is left for the second term. 3 going to negative 21, negative 7 times. Took 3x's, factor out 3x to the outside, no x left for the third term. To the only y to the outside, no y left for my third term. So my third term would just be negative 7. Okay, so that's how we factor out the greatest common factor. Another type of factoring problem. So this is very important. Factor out the greatest common factor is the number one thing we do. Every factoring problem, we always got to check for greatest common factor. The second type is called the factoring by grouping. Factoring by grouping is a very unique type of technique. It's a very particular type of factoring problem. It requires factoring twice. Okay, I will show you. It has two characteristics. You know this is a factoring by grouping problem if you solve four unlike terms. Gotta be four unlike terms. And there can be no greatest common factor between those four terms. Then you got yourself a factoring by grouping problem. All right. So I'm gonna scroll down a little bit. So what you see, this first example here, there's no greatest common factor between all four terms. And there's no like, and none of these four terms are like terms. So then that's a factoring by grouping problem. So the first thing you do is group the first two and the last two terms by underlining them. Gotta underline them. So I'm gonna group the first two and the last two. Then we're gonna factor out the greatest common factor between the first two terms, and we're gonna factor out the greatest common factor between the last two terms. So first two terms. What is my greatest common factor between the first two terms? Between 6 and 15, that should be 3. Between x squared and x to the third, that should be x squared. So my greatest common factor between the first two would be 3x squared. So 3x squared going to 6x to the third, 3 going to 6 two times, right? To factor out 2x from 3, 1x left. 3 going to positive 15, positive 5 times. To both factor out both x squared to the outside, so no x left for the second term. All right, factor out the greatest common factor between the first and the last two terms. So then, after you've done that, there should be only two terms left. And what's inside the parentheses should match. So that dictates how we go about factoring the last two terms. The last two terms, there's really no greatest common factor between the two terms other than 1. Okay, because I have to factor, I gotta put down 1. So if I factor out a positive 1, then I still end up with negative 2x minus 5, which the two parentheses does not match. Step number 3 here tells me that the two parentheses got to match. So I cannot factor out a positive 1. But since both of these terms, both of these last two terms are negative, I can factor out a negative 1. Because if I factor out negative 1, negative 1 going to negative 2x is positive 2x. Negative 1 going to negative 5 is positive 5. So if I factor out a negative 1, then my two parentheses will match. So by having a subtraction sign right here outside the parenthesis tells me here I got two terms. And since a parenthesis matched, that means what's in the parentheses are the same. So what's the same between all your terms are called the greatest common factor. What's the same between all the terms is called the greatest common factor. So once my parentheses matched, I can actually factor out my greatest common factor, which is the 2x plus 5 again. Because 2x plus 5 is two terms, so that's why I keep them in the parentheses. So if I factor out 2x plus 5 between from the first term, that means 3x squared should be left for my first term, right? We write down the greatest common factor, then we say times, open parentheses, just like I did with the first two examples. If I factor out my greatest common factor, 2x plus 5 to the outside, then the only thing left is my negative 1. So that go in the back. So that's my answer. Okay, factoring by grouping. Same thing with this example. Group the first two and group the last two. So as you finish in the factoring out the greatest common factor between the first two terms, it will give an idea what this next, what the parentheses should look like in the second parenthesis. Between 20 and 55, I know I can factor out a 5. To the third and m squared, I can factor out m squared. So between the first two terms, 5 going to 20 is 4 times. M squared going to m to the third, or take away 2 out of 3 m's, 1 m left. 5 going to negative 55, negative 11 times. Factor out both m squared, no m left for the negative 11. So what's inside the parenthesis got to match. Okay, what's inside parenthesis got to match. So, oh, I mistyped this again. This should be a plus sign right here. So, between the last two terms, in order for the parenthesis to match, I have to factor out a negative 1. Because if I factor out negative 1, negative 1 going to negative 4 give me positive 4m. Negative 1 going to positive 11 will give me negative 11. Because the parenthesis got to match. If the parenthesis does not match, then you will have to regroup them. You might have to group the first and the third with second and the fourth together. Okay. But this problem is to be a positive 11 in the end, not negative. All right. So once the parenthesis matched, what's inside the parentheses becomes my greatest common factor. So we factor that out. So what's left for the two terms got to be 5n squared minus 1. All right. Factoring by grouping. We'll do this quite a bit throughout the semester. All right, let's take a look at factoring trinomial. Factoring trinomial, these are factoring true trinomials. There are generally 5 different steps, okay? And the technique that we are using here is called trial and error methods. So I'm gonna go through this real quick, and then I'm gonna repeat myself while I'm doing this example. So what you do, first thing first, always try to factor out the greatest common factor if there is one. All right. If there is one, we're gonna factor out the greatest common factor and write what's left inside the parentheses, just like we did earlier. Then you're gonna write two open parentheses. If you don't have a greatest common factor, we're just gonna write two parentheses. So let's check this one here. There's no greatest common factor between the three terms. So we go ahead and write two parentheses. Step number 2, find all the factors of the first term and the last term. So basically what we are doing right now is doing FOIL method backwards. Find all the factors of the first term and the last term. First factor, 5. 5 is only 1 times 5. 6. 6 is 1 times 6 and 2 times 3. All right, because the next one is 3 times 2, which you already wrote 2 and 3, so you don't have to write it again. Step number 3, write the factor you just found inside the two parentheses accordingly. The factor of the first term go in the beginning of the two parentheses. The factor of the second term go in the back side of the two parentheses. So what you do is you're starting from the bottom, because the bottom set are the two closest digit multiplied equal to your product. You always start with those first. So 5 is 1 times 5. 5 is the first term, so 1 and 5, the factor of the first term go at the beginning of the two parentheses. The factor of the last term go at the back side of the two parentheses. So I'm starting with 2 and 3. Two closest digit multiplied together equal to 6. Then step number 4 says make sure the inner and the outer combined will give you the middle term. All right. So my inner and outer combined will give me my middle term. So what is my outer? My outer is 1 times 3. I'll have to do outer first. Right? Outer. 1 times 3 is 3. Inner, 2 times 5 is 10. My inner and outer combined, combine means add or subtract. Well, my inner and outer combined, can it give me a 7 in the middle? My middle term is 7. Can it give me 7? Yes, it can. How? The last sign tells you how. When the last sign is negative, so step number 5, if the last term of a trinomial is negative, it means the inner and the outer must subtract to get to the middle term. That's what I just did. The choice for the sign is a positive and a negative. The choice for the sign will be one positive, one negative. So it depends on the middle term. If the middle term is positive, then the plus sign gotta go to the bigger of the two inner and outer, because I need more positive than negative combined to end up with a positive 7 in the middle. So that being said, outer need to be a negative 3. So outer, remember, is 1 times 3. If it need to be negative 3, that would be 1 times negative 3. So the other parenthesis got to be plus. Put my variable in there, and I am done. X plus 2 times 5x minus 3. Okay, so these are the steps that going over your mind. Okay, when you're actually factoring a trinomial. So you take a look at this problem, for example. There's no greatest common factor again because at 47. So I will go ahead and write two parentheses. All right. Step number 2, find all the factor of your first term and find all the factor of your last term. So factor the first term 20, 1 times 20, 2 times 10, or I can say 4 times 5. 24 can be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So starting from the bottom, okay, put the factor of the first term at the beginning of the two parentheses. The factor of the second term put on the back side of two parentheses. So if I put it like this, okay, you see 4 and 4 together actually causes you have a greatest common factor 4. Because I did not have a greatest common factor earlier, I cannot put 4 with the 4. So I knew this is not gonna work. So I will swap them. If I put 6 right here, 4 back there, greatest common factor between 4 and 6 will give me another greatest common factor 2. So that tells me that I may not be able to use 4 and 6. I might need to use 3 and 8. Okay. So if you do this long enough, you will realize exactly what number to put and where. So now my outer, if I do it this way, my outer is 32. My inner is 15. Can 32 and 15 combined give me 47 in the middle? Yes, it can if I what? If I add them. So step number 5, when you do the signs, if the last term of the trinomial is positive, it means the inner and outer must add to get the middle term. The choice for the signs is either plus plus or minus minus, positive positive or negative negative. But that depends on your middle term. If a middle term is negative, then both of these in and outer got to be negative. And put my x in there, and I am done. 4x minus 3 times 5x minus 8. Okay, trial and error method. We tried 4 and 6 on the back side, it didn't work, so I moved on to the next set, 3 and 8. Well, Mr. Chen, why don't you use 2 and 10 instead? Well, if I use 2 and 10 at the front and using 4 and 6 on the back, that will continuously give me greatest common factor that I don't have. So that's why I went with 3 and 8. Okay. All right. So that's trinomial. Let's factoring difference of squares. Okay. So the way how you recognize difference of square problem is number 1, you only have 2 terms. Both terms are perfectly squared, and there's a subtraction sign in the middle. So those type of factoring problem tells you that this is a difference of squares. All right, so difference of square. So that means these answers are already squared. So what was my A before it was squared? What was x squared before it was squared? It must be what? X. It must be x. What was 16 before it was squared? It must be 4. There you go. So my answer, x plus 4, x minus 4. All right, that's how we factor out. That's how we factor difference of squares. Now, if you look at this example here, that is not difference of square, but there is a greatest common factor between the two terms. So if I find out the greatest common factor, which I believe is a 5, that should leave me with 4x squared minus 9y squared. So check inside the parenthesis to see if I'm factoring completely. If I check inside the parenthesis, what do I see? I see a difference of what? Squares. So I can factor again. What was my a before it was squared? What was 4x squared before it was squared? It must be 2x. Was my b before it was squared? Or was my 9y squared before it was squared? It must be 3y. All right, 1 plus and 1 minus. There you go. Now that's factoring completely. All right, I got this example here. This is factoring by grouping. So with I think it has difference of square embedded into it. So I'm going to group the first two and the last two. All right, from the first two terms, I know I can factor out x to the third power. Smallest exponent between the first two is x to the third. So take 3x from 4 of them, 1x left. All right, x to the third going to x to the third. X to the third going to x to the third got to be 1 time. So when I factor out all the stuff to the outside, that should left me with just a 1 there. All right, between the last two terms, I can factor out a negative 4x because I want the parenthesis to match because parenthesis has a minus sign here in the middle. So between the last two, if I factor out 4x, negative 4 going to negative 4 is positive. Take 1x from two of them, 1x is left. Negative 4 going to positive 4 is negative 1 times, right? If you're going evenly, it's 1 time. Remember, these are divisions. To the only x outside, no x left. So now my parenthesis matched. So if I factor again, oh, check this out. This looked like a fraction by grouping problem, isn't it? But there is a greatest common factor here. Let me finish this. So if I factor this one out, this is going to be x minus 1, right? Greatest common factor times first term should be x to the third minus 4x. So this is not factoring completely because in the second parenthesis, if you checked, this is x to the third, there's another x there. So that means I can actually factor out another x. So this whole problem started with has a greatest common factor between the four terms. So I'm going to scratch it on purpose. So if I will factor out the greatest common factor x, then what's in the parenthesis now should be x to the third minus x squared minus 4x plus 4. So what's inside the parenthesis is actually factoring by grouping. Check this out. So this x remains outside, right? Factoring by grouping. So these two, I can factor out an x squared. So from these two, I should end up with x minus 1. The last two terms, I can factor out a negative 4 as the greatest common factor because that will be negative 4 going to negative positive x times. Negative 4 going to positive 4 is negative 1 times. So now the two parentheses matched. So this x is still outside, right? My greatest common factor x is remain outside. So now these two are greatest common factor. So I need to factor that out. So what's left will be x squared minus 4. Which are, so I'm not writing this big parenthesis anymore because right now everybody is one term now. So I don't need another extra big parenthesis. So this is a difference of square if you check it again. So that can be factored again. So x is x minus 1, and that will give me x plus 2 and x minus 2, right? This part is a difference of square, can be factored again. So a problem like these, it has difference of square embedded into it. On top of that, first thing to do was to factor out the greatest common factor. So from this line earlier, if I would notice, if I can catch myself by saying, okay, another x can be factored out along with the x minus 1. So what's in the parentheses should be x squared minus 4, which would be this. Then I can factor again. So always check what's inside the parenthesis to know if we factor completely. All right. What type of factoring problem is this one? So make your choice. All right. Question number 2 is going to be on the handwritten portion. Okay. The entire question 2 is on the handwritten portion. So I got it up here. So I want you to do factoring trinomial. So question number 2, number 1, find all the factor of 3. Okay, so write 3 is equal to 1 times 3, right? That's only one set of factors. Number 2, find all the factor of the last term. So this problem has no greatest common factor, so we jump straight to step number 2, 28. So you can write 1 times 28, 2 times something, okay, so on and so forth. Starting with the last set of factors, so it's whatever the last set of factor you got from the 28 and the 3 right here, write the factor you just found inside the 2 parentheses accordingly. So since there's no greatest common factor, 2 parentheses, right? 1 and 3 got to be in the front because the factor of 3 is only 1 and 3. And whatever the last set is right here that you're going to find, you put on the back side of 2 parentheses. And then number 4, I want you to demonstrate, okay, the inner and outer. So let's do outer first. Outer, inner. So I want you to demonstrate this times this is going to be outer. This time this is going to be inner. So I want you to demonstrate that you will somehow end up with positive 17 in the middle. Okay, with the inner and outer combined. So you don't have to fill in the signs in here. Okay, you can just follow, because filling the signs, when we factor in the trinomial here, write the signs in there and write the variable in there is the very last step. Okay, and this very last step come from make sure the inner and outer combined will give you a middle term. Okay, so when I say demonstrate the inner and outer combined, it's referring to this part right here that I did. All right. Question number 3 is also on the handwritten portion. All 3 of them on the handwritten portion. So you can do number 1, number 2 right here from the problem. Underline the first 2 terms. Underline the last 2 terms. Do not use parentheses. Do not use parentheses. That's incorrect. Because when you use parentheses, you make them look like something times something already. So group them by underline them, and factor out the greatest common factor between the first 2 terms, and factor out the greatest common factor between the last 2 terms. So that will be the answer for 3. So once the parenthesis matched, factor out the greatest common factor again and finish your problems. Okay, so that's all you got to do for question number 4. All right, so just a quick review on how to do greatest common factor, factoring by grouping, difference of squares. Okay, there's actually 3 other one I didn't mention. The the sum and difference of cube and perfect square binomial. I didn't mention that, and that's okay. If we encounter it, well, I will show you. But make sure you know how to do these 3 types of factoring. All right. Thank you for watching.